Okay, let's see how this goes, shall we? I'm just going to go ahead and roll over here and not know what my computer stuff is doing again. But I have this. This is an electronic snap kit that I got for Christmas many years ago. And hopefully, wait, I can actually hear myself. Yay! Um, many years ago. And it was cool. And it got me interested in electronics. So we're going to go ahead and take a look over this thing. Throw that over there. What's this? Oh, whoops. Gotta get that out of here. Come with a little booklet here, and it has instructions in it. Lots and lots of instructions. And it comes with various projects you can do. You can, yeah, like you can hear a motor. Actually, there is a total of 303. You could get one that had well over 500, I think. They start out awfully basic, like a electronic light and switch, and DC motor and switch. You can hear a motor, adjust the sound level of various things. You can do a series, parallel, basically a whole bunch of things. Flying saucer. Basically, we're just going to go ahead and go over this a little bit. Basically, this is the layout of all the things inside the package. You have a little grid. Oh, let's get this out. You have a little grid thing that everything snaps to. It's clear. You can see through it. Then these here are all the various things that come with it. We have some spare light bulbs for the light bulb thing. These are your fancy connector things that you use to connect everything together. I am missing one piece from what I remember. And of course you have various sizes. These are all snapped together. Get all these guys out of here. Basically these are various sounds that you can make. That's useful for later. This is the spinning blade for the motor. Right here. Right there. Let's go ahead and take a quick roll over here. Is everything in frame? Barely. Okay. Right there. Motor's right here. This is a little tuny dial thing. Light detector. Various things you can add yourself. I forget what this is for. A button, right? A push a button. A slidey switch. Various resistors. And various capacitors, which they probably de-aged. They probably aged by now. Light bulb thing. And more pointy bits. Oh, and a speaker goes right there. I think all this stuff works. It has to be a good 10 years at least since we've done this. So we're gonna just go ahead and start assembling things together and see if we notice anything breaking. Obviously, I'm gonna go ahead and move this guy out of the way. I'm gonna stick that right there, and I'm gonna stick this little booklet right here so I can actually see what I'm doing. I have tested batteries, and if not, we have more. Is that in frame? Yes, that's perfectly in frame. And we can kind of, if I move this a little bit this way and a little bit that way, can we see almost the whole book? Almost the whole book. Okay. Good enough, good enough. So we're going to actually just go ahead and start with the electronic and light. So we need one of these guys. Snap it right there. And we need our little switch, S1. Stick him like, yeah, technically right there will work. Right like that. And now we need our light switch, our light. Put it there. Now we need to connect all these guys together. I don't know if they still make these snap kits. And now we need to grab a 3. And we can so they tell you to put it here and then do 2 smaller ones together. But we're lazy, so we're going to just go ahead and do that right like that. Because I'm smarter than they are, or something. Now we need an actual, is this on or off? That's technically on. Now that's off. Okay, where's our light bulb? Here we go. Here is one. Actually, oh, nope. There's one included with the package. And there we go. Light bulb is lit. Now, it's not very bright, possibly because the batteries are dead. And because I am smarter than I was 10 some odd years ago, we have a multimeter because we can poke things and determine what stuff's happening. So I'm thinking, I ain't exactly smart, but I'm hopefully not completely stupid. If we go ahead and go from here to here, we should get a voltage, I think, of that's millivolts. So if we go ahead and turn this off, I'm thinking we should get a voltage here. Yeah, so 2.8 volts. Now each of these is, so if you check this one right here, we get 1.5, and this one here is 1.3. So this should get us our 2.9. And so obviously if you try to go between here and here, it doesn't work because our switch is off. Wait. Oh, well, this is ground, so obviously it will technically work. But obviously if you go here to here, there's nothing there. Continuity, which is fancy. Where is it on here? This one? No. Wait. Is it this one? I can't tell which one's the beepy noise one. Yeah, that is the beepy noise one, I think. I don't 100% know what I'm doing. But basically, this is resistance. And obviously, if we touch them two together, it should go really low because there's basically no connection between the two. And there we go. And if we check here and here, we should have practically no resistance. But if we go between here and here, it should not work. I think. You know what? I don't know what I'm doing with the resistance part, but I do know what I'm doing with the voltage bit. We can see that voltage here, 2.9. Let's go ahead and turn on the light. And we'll go ahead and see that the voltage is now 2.5 because there is a load on the system. And that we can tell that because, yeah. Okay. Actually, do I have a fresh set of batteries around here? No, I don't. Okay, well, that's light. Simple enough. Okay. If we break out these two pieces, set that aside. We'll be coming to back to that. ML. No, we'll not be coming back to that I know of. At least not yet. Now for the DC motor and switch. Okay, there's that. Grab this. And stick that like that. Stick that there. Stick that on top of that like that. Now for this, I'm actually going to follow their instructions. And go like that. There we go. And now where is the... There we go, and there we go. Now we have it off. Set that on top. Hey, look at that. It spins. You don't want to stick your finger in it because it hurts. Actually, no. That is not hard enough to hurt. Cool. So that's that. Let's go ahead and do project number 3. Okay, actually, for project 1, build the circuit shown on the left by placing the parts with black 1 next to the... When you turn on the switch, the current goes through like that and turns on the light. When you turn off the thing, the current no longer flows and the light turns off, obviously. DC motor, when you turn on the slide switch, current flows from the batteries through the motor, making it rotate. Place a flam blade on the motor shaft and close the slide switch. It'll basically, physics happen. Basically, we're changing electrical power to mechanical power using the DC motor. And an electronic motor is just easier to control than gas or diesel engines. They each have descriptions here. Okay. Here the motor. So a motor uses mechanism to convert electrical energy into mechanical spinning motion. As a motor shaft spins around it, disconnects several sets of electrical contacts to give the best magnetic properties. As these contacts are switched, an electrical disturbance is created, which the speaker converts into sound. If you replace the motor with a 6-volt lamp, L2, it will then work the same, but only make noise when the lamp is turned on or off. Oops, sorry about that. So let's go ahead and build this one, because why not? Okay, it's saying to go completely tear apart this one here. Now, because I am slightly smarter than what they are, okay, not slightly smarter than what they are, is I understand what they're trying to do, I'm going to build this however I want. Because, well, personally, I want to go like this. Right there. And we're going to connect these two like that. Connect these two like that. And then this guy goes over here. We're going to move him a little further away. That way we can easily reach things. A 3-1 goes right there. And another 3 goes right here. I'm building it unlike the instructions, but the instructions can go fly a kite because I know what I'm doing. I don't know if you can pick that up, but you hear a slight purr noise from the motor from this right here. And if we stop this, you'll notice this will go ahead and like take some time to speed up. And you can kind of hear the noise increase and decrease as if we go ahead and speed up and slow down the motor. That is kind of cool. Okay. Let's go ahead and turn that off and stop the motor. Okay. Let's go ahead and number 4. Build the circuit shown on the left, then leave the fan off the motor. When you turn on the slide switch, the music may play for a short time and then stop. After the music stops, spin the motor with your fingers. The music should play again for the short time and stop. Now replace the 100 milliohm. This one doesn't really make much sense, to be honest. Is there another one that's more interesting? Oh, hey, here we go. To show that the lamp can indicate when the fan is running. Okay, let's see here. Okay, let's build this one. Okay, let's see here. So we need a battery pack, slide switch right there. Where is the light one? I placed it somewhere. Back here. And we're going to place that right there. We're going to just build this in the general way they have it, but I'm going to be a little bit more however I want kind of thing. Let's go ahead and do that right there. Now let's go right there. And that's it. Okay, so let's connect these together. That one goes right there. That one goes right there. And then we're going to go ahead and go like that to get that there. We're increasing resistance, but it really shouldn't matter that much. This is going to be the only interesting one. Actually, go right like that. Like that. And that, and like that. Okay. Now, shoot, what's going on? Do I have the thing backward? Oh, I do. Oh, I had this piece backward. Direction matters, folks. Okay. Wait. We have the positivity, right? Positive and negative, right like that. Yep. Okay. So in theory, when this is turned on, wait. Oh boy, what did we, oh. Let's make sure all our contacts are solid. There we go. Okay. Now in theory, that light should turn on when the motor starts spinning. In theory. And there you go. You can see it's very dim, but it's turned on. It's very dim, but it did turn on there. So So yeah. Huh. And if you notice, light gets dimmer as the motor speeds up. And it also doesn't go quite as fast as if the other thing's in there, which is interesting. Now, I'm curious, and I'm going to play with this because, you know, I like living dangerously. I'm thinking if I place this here, I need 2 of the pointy bits. I'm going to stick one right there. And one right there. And then if we stick this here, currently that shouldn't do anything, but as you can see that, still, and then that dims. Now in theory, due to lower resistance, it should essentially take a path around the light. Yeah, because see, now it's taking a path around the light, and that's spinning up more. Because this here adds resistance to the electric running through it, meaning that this gets higher voltage. This takes away some of the voltage and power, so to speak. And now once we remove it, that takes out some of the power, and it doesn't spin up as fast nor as fast in general. Interesting. So that's the thing that the things that electronics do. Okay. How long have we been recording? 15 minutes. Let's go for another 15 minutes yet to make a total of 30. Okay. Okay. So now they want us to build them in so that was in a series, as in it goes from here to here to here to here first. And now it wants to show in a parallel, which means when they're built in a row. So they want us to go like, let's go ahead and do it like, how do I want to do it is the question, actually. Because I like to claim I'm smarter than them, which in actual reality, I'm not. I just like doing it my way. Okay. Nope. Come on. Butterfingers. There we go. And we're going to want to go ahead and go like that. And then need another one to go like so. Actually, can we get... Yeah, there we go. Wait, we can let's get a slightly bigger one yet. There we go. Now let's go ahead and connect like that, and like that, and like that. Now we only need to go here and here. There we go. And now, instead of being in a continuous motion, these two are now kind of separate from each other. So, when you first turn on the slide switch, both the fan and lamp should turn on. The fan will take a while to start turning due to inertia. In this connection, the lamp does not change the current to the motor. The motor should start a little bit faster. Okay, let's see what happens. So that stays the same brightness and actually increases in brightness as the motor spins up. It's not quite working as they expected due to how it is. Because you see how the thing speeds up? It's not quite working how they expected it to, but I'm assuming it's due to how batteries and various resistances are and how I set this up. But, in theory, basically, they now are basically each their own connection to the batteries instead of taking power away from the other. But electronics are weird sometimes. Okay, light emitting diode. To show how resistor and LED are wired to emit light. Okay. So, let's go ahead and rebuild this circuit right here. Light emitting diode, otherwise known as an LED. They are more common now than they were when this kit was made, I can tell you that much. Okay, this needs to be moved up 2 steps. Actually, just 1 step. This switch needs to go right. I'm gonna actually build this upside down. Technically, it shouldn't matter. I think. And red LED should go this way because we're going. I don't actually know if it matters. But we're going to go ahead and attempt to build this upside down because I'm a genius. And I'm being sarcastic. I'm actually quite stupid sometimes. And now we want the R1. This resistor. Stick that right there. Stick that right there. There we go. And right here. Okay, what does this do? Okay, it lights up. Okay, cool. When you turn on the side switch, current flows from the batteries, through the switch, through the resistor. Actually, it's going the wrong way. It's going the wrong way. You know what? We probably should actually just build this exactly how they state. There. Yep, this needs to be rotated 180 degrees. And can I actually, does this have a data manufacturer on it? Ages 8 to 8108. Oh man, I'm too old for this kit. Made in China. It's from Radio Shack. 28-287. But is there like a trademark time and date on this package now? Now I'm curious. Wait. This product contains chemicals including lead known in the state of California called birth defects. Wash hands after handling. Okay, what if I don't wash my hands and eat food? Will that be a problem? I hope that's not a problem. 1-800 The Shack for a phone call. Cool. Okay. Does this have a trademark in it? I want to know trademark time and date. Revised 2005. That is 16 years ago. Almost 17. I feel old. Thanks, guys. Okay. Turn on switch. Light lights up. We are cooking, boys. So in theory, this is 100 ohms. If we get a 1000 ohm resistor, it should in theory, oops, I dropped it. It should in theory make the LED dimmer. Because, yeah, see, look, it makes it dimmer because this has more resistance, meaning it makes it dimmer. Now, in theory, if I go like this, it makes it brighter because we're reducing the resistance because this doesn't have any resistance. And so instead of going through the resistor, it goes through this, meaning it makes the LED significantly brighter. But instead, we're not supposed to, make it too bright, otherwise it may cause issues. So that's what it claims. Oh, and obviously, this is a switch, but, I just realized my watch probably has more technology than this entire kit by a mile. Okay, and fancy thing. Stick that there. Stick that there. Stick that there. And now we have a button. Button appears to be slightly broken. There it doesn't work. There it works. There it doesn't work. Cool. But anyway, that's a thing. One direction for LED. Oh, if we go ahead and turn it around, it doesn't work. So in theory, if we turn this around, it won't work because we can only have electric go one direction through the LED. According to my instructions right here. Actually, let's put on this slightly, make one that makes it brighter, which is this one. Right there. I really should use my multimeter to see if I can actually measure those things for distance. Now, in theory, this doesn't work. Yeah, it doesn't work because you can only put electric one way through this LED. You can't make it go this way. The electric only goes this way, and the electric can't go through this LED in that direction, but it can if we turn it around. Okay, conduction detector. Oh, right. If we go ahead and stick, we need two of these little guys. Do I not have more than one? Here we go. If we go ahead and go like this, and there, if we use anything to touch across these two, gotta make sure our LED is the right way. Whoops. There we go. Now, in theory, anything that we can touch together on these two ends will make the LED light up. See? Now, in theory, that will work with just about anything. Like, for instance, this paper clip. See? Cool. Oh, flying saucer. Okay. So, you recall how the blade was spinning the other time when we did it. So, this has to do with polarity of motors in a DC circuit. If we go ahead and stick this right here, and we go ahead and we have 4. We have multiple 4s? We have multiple 4s. Okay. We're going to want to keep our hands slightly a bit away from this. Let's go ahead and stick that right there. That one we're going to go ahead and stick like that. Right like that. And then we need a 4 to go here and here. A 2 to go here and here. And a 2 to go here and here. Hopefully we don't lose the blade. Because let's turn that off to make sure it doesn't spin up right away. There we go, and there we go. And set this on here. Now, it shouldn't take off. It should be blowing the air up. Yeah, it's blowing air up. It's quite loud as well. It's blowing air up, meaning it's pushing the blade down onto the motor. However, if we go ahead and move this guy like this and turn it 180 degrees, and the electric will be flowing the same way, but, okay. So, now this, in theory, should fly up at the camera. We don't quite have enough juice, but we can solve that problem. Other battery pack. And we're going to stick you right here. Stick you like that. Now we need 3 more of these guys. So since we went from 3 volts of power to 6 volts of power, basically, so these batteries are in serial, not parallel. So basically, each one of these batteries is 1.5 volts. Basically, volts is how much oomph the battery has, so to speak. And so 1, 2, 3, 4. 4 times 1.5 is 6. We stick this one here, and so instead of 2 of them, we have 4. Now, in theory, that should give us twice as much oomph. And there it went. Ow. It stuck in my finger. So as you can see, it spun up much faster and went flying. Oh, right. Yes. Basically, we can put something like... Also, if you notice, another thing about this, can I grab my LED? Here we go. This guy right here. And now we need to go from here to here, and here to here. And now we need, is this the 5? Yeah. So there we go. Okay. So now we added in the light bulb. So if we go ahead and turn this on, the bulb is much brighter and the motor spins up way slower. Because this is providing additional load onto the batteries, essentially, reducing the amount of power the motor gets. You know, fancy things like that. Oh, yeah. Oh, obviously. A fuse, so to speak. If we take out this, everything stops because we essentially create a break in the circuit. And we can kind of, use the 2 contacts to do a thing. But anyway, I figured that's pretty relatively simple. Let's see here. A 2-speed fan. Okay. So what we're going to do is go like this. We're going to go ahead and keep the 2 battery packs because I like playing with power. Just going to go ahead and connect them together like that. First things first, we're going to put the motor right there. Excuse me. That guy's going to go right there. This push button, we're going to go ahead and put right. Actually, you know what? We're going to go like there and there to keep our hands away from that blade as far as possible. This is going to go here to here, right? And then they tell us to go... Okay, yeah, I see how they're going to have us do this. Do we have another 4? Here we go. Okay, and now we're going to want to go ahead and go there. And basically, this is going to teach about the path of least resistance. So electric does not like having to do work, in general, kind of like me. So therefore, it'll take the path of least resistance. However, this is no path right here because it can't, unless this switch is pressed, there is no path for it to go through. So therefore, the fan will be slower due to the fact that this thing is providing load to the batteries. However, when we press this switch, that is always fun to do. When we press this switch, the electric now can travel straight through here, not turning this light off, and allowing all the power from the batteries to go into this electric motor right here. Because cool! And also it doesn't like doing work, so therefore this is less work than what this is. Let's see here. Ooh, musical doorbell. Why not? How much time have we been doing this? 33 minutes. Okay, we're going to do a musical doorbell yet. Because why not? Okay, we're going to go ahead and remove this, remove this, remove this. Okay, let's just set all this stuff off to the side. I'm going to have to remove a battery pack. Okay. Okay. I'm going to leave that switch right here. We're going to somewhat follow this thing's, where did I put the blue thing? Here it is. Okay. So that's going to go like so. They want the 6, which is the biggest boy we have. Nope, sorry, we have a 7. This is going to go like this. This is going to go like so. You know what? You can probably see reflections in my watch from places. Oh well. This needs to go over one more. There we go. Speaker is going to go here. And this is going to go right here. We need the resistor. This is 1 ohm, 100 ohms, right there, 100 ohms. That needs to go right there. Now, we need to get the button right here. And we need to get the number 3 and go here. And now we need a 5 and go here. And get a 2 and go here. And a 2 and go here. So if we turn on the switch... Okay, let's see here. Okay, each time you press the switch doorbell button, the song will play again and stop. Okay. So when we turn this on, it'll play one song. Okay. Then when we press the button, if we press the button, something's broken. Wait a second. Something is not working as intended here. Something is not working as intended here. I can tell you that much. Because something is not working as intended, because it should be that only when I push this button does songs play, but it's not like that. Now when I press this button, something's broken. Not entirely sure which, but something is broken. I think that's what we're going to stop with at the moment. Because otherwise we start getting complicated. Otherwise, it gets complicated. But basically, there's a whole bunch of things we can do. Because you can actually build an AM radio with this stuff. And maybe we'll see about doing one of them. Space War sounds, capacitor stuff, a mind reading game. I don't know quite how that works. Changing a siren, Symphony of Sounds. Lamp brightness control. You can store electric with things. Multi-speed fan light, electric fan, motor delay, motion detector, motor rotation, motor activated burglar alarm, high pitched bell, wet finger detector, spacey fan, lasting doorbell, lasting clicking, paperclip compass, electromagnetic storing energy, light controlled LEDs, AM radio, there it is, 244. And interesting. Yeah, there's a bunch of stuff on this. Anyway, I am going to go ahead and turn that off and stop recording this, and we'll see what happens. We'll see how things came out. And I will talk with you people later.